Pavan. Myself is a Pavan. Today I am going to Nernest equation. So here to write the Nernest equation, so here the definition of the Nernest equation is algebraic sum of the single electrode potentials. Single electrode potential, that is called as what? Nernest equation. So here next one is, so to write the Nernest equation, so we need one chemical reactions. So here I am going to take one of the chemical reactions. I am not taking, so here the entire thing, just for example you can consider, so here the zinc and copper electrode, zinc and copper electrode. So in this, zinc is, so here the value of zinc is minus 0.76, copper is positive 0.34 volt. So here based on these values, the highest reduction potential, we know that highest reduction potential values is always acts as a cathode, the lowest reduction potential values is acts as a anode, right? So now we are going to write one of the chemical reactions. This chemical reaction is, so in case of zinc, so here the anodic reaction, anode you are going to take. So here that anode means which loses electrons. So here the Zn2 plus 2 electron. So this process is called as what? Oxidation, we know that. And next one is cathode. Cathode, in this cathode the copper is acts as a cathode. So whatever the releasing of electron takes place from the anode, that electrons will gain by the cathode. So 2 electrons, and therefore it become as a copper. If you write overall reaction, these two electron cancel, and next zinc and Cu2 plus, so here Zn2 plus Cu. This one is, so here the overall reaction. This reaction I am going to take here. So here the zinc, and next how you write? Zn2 plus, that undergoes oxidation, and next copper, which undergoes a reduction, which gains electrons and it forms Cu. This is a reaction. This is a one reaction. By using of this reaction, we need to write the Nernest equation. What is the Nernest equation? So Nernest equation is, so we have one mathematical equation is there, that is E equal to, so here the E naught minus, so here the 2.03, so here the 2.303 RT by, so here the NF, so here the log of concentration of product by concentration of reactant. That is called as what? It is a Nernest equation. So using this reaction, using this chemical reaction, we need to write the Nernest equation. How we are going to write? So here for example E equal to, so E naught minus, so here the 2.303, so here the RT by, so here the NF, and log of concentration of product means this you need to take concentration of Zn2 plus and concentration of Cu divided by, this is a product. Concentration of reactant means we need to take concentration of zinc and concentration of, so here the Cu2 plus. So we know that, so what is the Nernest equation? So here the Nernest equation is, generally Nernest equation is used to, so here the used to calculate, so here the potentials of electrodes, so here the potentials or charges.
So these are the basic steps to perform casting process. In that, first one is pattern making. Already we discussed about pattern here. It is first step in the casting. Pattern is nothing but whatever the component we are going to make, the exact duplicate, the exact model of the casting will be pattern. So before performing this casting process, we need to do, the first step is pattern making. So already we know what are the components we are going to make with the help of the casting. So accordingly we need to prepare the pattern, but in that case also we have to consider some basic parameters, like any shrinkage will be there in the material. It is completely based on the type of material, either it is a lighter material or stronger material, and how much shrinkage will be there. Either it is a lighter material or we are going to manufacture a thin cross section or thicker cross section. All those parameters we need to consider while making a pattern. So for that we need to know about the allowances also. Okay, allowances is nothing but it is the difference between the dimension, whatever the dimension which is actually there in the product and whatever the dimension we are going to give it to the pattern. So those parameters we need to consider while making a pattern, then only we can get the casting with an accurate size and shape. So it is duplicate of the casting. And next, second process is moulding. Moulding is nothing but, already we have discussed here, there are two portions in the mold making process. These are, here one is scope and another one is drag portion. So in this, whatever the pattern we have made in the first step, that pattern will be placed in the mold box and we need to remove the pattern, and same impression will be formed within the moulding flask, because this flask is completely filled with the moulding material. Generally we will prefer sand as a moulding material because it is having all good properties which helps to get the accurate casting. So because of those properties we will prefer sand as a moulding material. Here this complete flask will be filled with the sand material. It is completely rammed and packed to get the accurate shape of the mold. So into that sand we are placing a pattern. For example, assume I am going to prepare this product as a casting. So I will place this in the moulding flask. If I remove it, same impression will be formed in the flask. So that we are calling this pattern as a duplicate of the casting. So whatever the impression or whatever the shape which will flask is called as mold cavity. Okay. So into that cavity we are pouring the molten metal. That is the third step here. That will be called as pouring of molten metal. Means in this stage we are completely melting the material from one state to another state. Means from solid to liquid state we are completely converting the material. That is why it is called as molten metal. Means above the melting point we are melting the material. Means whatever the material you want to use to prepare the components, that material need to be converted from one state to another state. So once it is converted to liquid state, that metal is need to be poured into the cavity which is already prepared here. So into that cavity with the help of required tools and accessories and by taking some safety measures we need to pour the molten metal into the cavity. And next step is fourth one, solidification of the casting. Solidification is nothing but in the third stage we are converted the metal from solid to liquid state, and again in the fourth stage we are allowing that molten metal to solidification. It is based on the type of material. Some materials takes less time for the solidification, some takes maximum time for the solidification. So based on the temperatures and based on the type of the material and based on the quantities it may vary. So solidification is time will be calculated based on all these parameters. So we need to allow it to the solidification. So that is the fourth step. So once it is solidified, we need to cool it to the room temperature. For that we can add any coolants or we can leave it to cool at an atmospheric state. And the last step is breaking of the mold. This is the final step in the casting. So whatever the product we have prepared by using this, that need to be removed from the mold. How to remove it? We need to break the mold to get the casting, and it is placed in the sand. Already we have discussed about that in the second step. So all those sand particles will be sticked to the casting. So we need to perform casting process. So it is completely based on the requirement. If we want to get the product with a greater accuracy, then we need to perform finishing processes. Okay, based on that we have to machine the component. We can use any finishing operations based on the level of accuracy. That is the final step. So the major advantages of using this casting process is it is suitable for manufacturing any shape of the component. It may be a simple shape or it may be a complex shape. It is suitable to cast any type of product which are having very complex shapes or which are very easily converted, and it is also suitable to cast the components which are larger in size and which are very smaller in size. Means to cast intricate components also this casting will be preferable, and it is very easy to perform compared to other processes, and the cost of the process is also very low. So we will prefer mostly casting as the fabrication process. So by this discussion I want to you be able to answer to my question. Give me any one applications where using casting as one of the process. Any one application in any area. Give me one application of the casting.